All right, let's take a look at question 14. We're going to find a simple basic a right and a left end behavior model for the function f of x equals the natural logarithm of the absolute value of x plus 2 plus x to the third over 2x plus 5x squared plus 2 to the a negative x plus sine x. Okay? All right, so before we start, let's go over the steps for finding the end behavior model of a function. So first thing you want to do is you want to find the limit as x approaches plus or minus infinity, plus infinity for the right end, negative infinity for the left end of the add-in functions. All right, so in this case we have four functions, 1, 2, 3, 4. So we're going to take the limit as x approaches infinity of each add-in function. And then secondly, for functions, let's call it the add-in functions approaching infinity. For the add-in functions, put that there. All right, so for the functions that are growing in perpetuity, so functions approaching plus or minus infinity, you compare their growth rates. Okay, so after comparing their growth rates, the fastest growing function is the end behavior. Okay, so the fastest um, is the end behavior in that direction. Okay, now how do you compare growth rates of functions? Well, there's a hierarchy that I normally show to my students. So let's write down the growth rates of some functions that you come across when determining the end behavior model of functions of this nature. Okay, so growth rates. Um, the slowest growing one is the natural logarithm of x. These ones are the functions that actually grow to infinity. Okay, natural logarithm of x is the smallest, followed by x to the a, the polynomial function, and then that's followed by a to the x, the exponential function, and then x to the x. That's the fastest growing one. All right, so let's keep that in mind. So first thing we're going to do, the a part, we're going to find the right end behavior model. Okay, right end behavior. So we're looking at infinity. So to find the right end behavior, what we're going to do is we're going to find the limit as the four add-in functions approach infinity. Okay, so what are our add-in functions? There are four of them. Let's enumerate them. The logarithmic function is 1, rational function is 2, this exponential function here is 3, and then this trig function is 4. All right, so let's go ahead and do the comparisons. So for the first function, for 1, we're going to find the limit as x approaches infinity of the natural logarithm of the absolute value of x plus 2. We can find this limit by direct substitution. We have the natural logarithm of the absolute value of infinity plus 2, which is equal to the natural logarithm of the absolute value of infinity, and then this one is equal to infinity. All right, let's look at the second add-in function. We're going to look at the limit as x approaches infinity of x to the third over 2x plus 5x squared. Since we're tending towards infinity, we're going to compare the growth rates of the fastest growing term in the numerator and that of the denominator. So look at this one right here and this one right here. And then that leaves us with the limit as x approaches infinity of x to the third over 5x squared. All right, this goes so slow that we can neglect it, okay? So if we reduce this, we're going to have the limit as x approaches infinity of x over 5. Because x squared goes there x times. So we plug in infinity, we have infinity over 5, which is equal to infinity also. Okay, let's look at the third function. Limit as x approaches infinity of 2 to the negative x is equal to the limit as x approaches infinity of, you can write it as 2 to the x, 1 over 2 to the x. Now with direct substitution, we have 1 over 2 to the infinity, which is equal to 1 over infinity, and 1 over infinity is 0. So this one basically approaches 0, it doesn't even grow, it shrinks. Let's look at the last function, which is your sine function. We're going to consider the limit as x approaches infinity of sine x. So what do we know about the sine function? We know that even at infinity, the sine function oscillates between 1 and negative 1. Okay, so this one is it going to oscillate between negative 1 and 1. So it's bounded. It doesn't even grow. It just stays within these boundary regions for forever. All right? So the only functions that we're going to compare the growth rates are the functions that are growing forever, the functions approaching plus or minus infinity. So in this situation, only function 1 and 2 fit that description. Now, if we look at function 1 and 2, let's compare them. Which one grows faster? Now, for function 1, we have the natural logarithmic function. And then for function 2, if I want to take the basic function as x approaches infinity, this function 2 is going to basically look like x over 5, okay, at infinity. So what we're going to be comparing is we're comparing the natural logarithm of the absolute value of x plus 2 with, we can copy down this function or in its simplified form, x over 5. So which one grows faster at infinity? Is it this function or this function? Remember, in our growth rates, the power function grows faster than the logarithmic function. So guess what? This function right here, x to the 5th, x over 5 grows faster. You can look at this as 1 over 5x to the first power. At infinity, this grows faster, okay? So since this grows faster, this will be our right-hand behavior model, okay? So the right-hand behavior model is x over 5. You can write down this function, x to the 3rd over 2x plus 5x squared, but this is a simplified form, okay? This is actually how this function behaves at infinity, okay? Now what does this mean? Let's write down the meaning. The meaning is that the limit as x approaches infinity of the original function divided by this simple function right here, x over 5, is going to be equal to 1, because at the right-hand behavior, these two behave exactly alike. They have a perfectly identical growth rate. So when you divide them, you're going to get 1. So there goes your right-hand behavior model. All right, let's look at the left-hand behavior model now. Okay, so we're going to look at the left-hand behavior model. So left-hand behavior model. For the left-hand behavior model, we're looking at what happens as x tends towards negative infinity, okay? So the same process, we're going to find the limit as x approaches infinity, negative infinity of the add-in functions. So let's start with the first one, limit as x approaches negative infinity of the natural logarithm of the absolute value of x plus 2, which is equal to the natural logarithm of the absolute value of negative infinity plus 2, which is equal to the natural logarithm of the absolute value of negative infinity, which is equal to the natural logarithm of infinity, which is equal to infinity. Okay? And then for the second function, we're looking at the limit as x approaches negative infinity of x to the 3rd over 2x plus 5x squared. Now we can compare growth rates here again since we're tending towards negative infinity. So the only terms that actually are growing the fastest in the numerator is just x to the third. In the denominator is 5x squared. If you reduce that, you get the limit as x approaches negative infinity of x over 5. And then when you plug in infinity, you're going to have negative infinity over 5, which is equal to negative infinity. All right, the third one, we're going to find a limit as x approaches negative infinity of 2 to the negative x, which is equal to the limit as x approaches negative infinity of 1 over 2 to the x, which is equal to, by substitution, 1 over 2 to the negative infinity, which is equal to 2 to the infinity because you reciprocate this term due to the negative exponent. 2 to the infinity is infinity. For 4, the limit as x approaches negative infinity of sine x. We know how sine x behaves, right? Sine x oscillates between negative 1 and 1 way to negative infinity also. All right? So the only candidates that keep on growing forever are the first three: 1, 2, and 3. So for 1, we have the logarithmic function. For 2, we have the polynomial function, a linear function. And for 3, we have a exponential function. So which one grows the fastest? Remember in your growth rates, the slowest is the logarithmic function, followed by your exponential function. Followed by your polynomial function, and then your exponential function, and then x to the x. So you notice that the fastest growing one here is absolutely number 3 because that's the exponential function right there, okay? So your left end behavior model, left end behavior model is what is it? 2 to the negative x. Okay, because that's the fastest growing one. What does this mean? The meaning is that the limit as x approaches negative infinity of the function over 2 to the negative x is equal to 1. All right, so that's that. All right, so you can click on next to advance to the next problem, or you can go back to the main menu by clicking main test. If you need want to scope over more examples on end behavior models, click on here for more examples, and don't forget to subscribe for updates to other cool tutorials such as this.